when we go ahead and solve equations, we have been working with only one of these three options or outcomes so far. We've been finding equations with one solution. Good morning. Anytime we have an equation, thank you, with one solution, it looks something like x equals 2, y equals 1/2, or b equals 0, something like that. Letter equals number. That shows us we have one solution. The only answer that makes this equation true is 2. The only answer that makes that equation true is 1/2. And the only answer that makes this other equation true is 0. Letter equals number. We could even write that in. Letter equals number. Like I said, every equation we've solved so far has had this outcome. But today we're going to take a look at two different outcomes. We may also have many solutions. It's kind of like how, here, I'll give you an example. This is the key to my classroom, right? If I go next door to Ms. Karan's classroom, this key's not going to unlock that classroom. If I go over to Mr. Duch's class, this key's not going to unlock that classroom, right? This key has one solution. My classroom door. But Mr. Amy and Miss Swift and Miss Park all have a key that unlocks every door on campus, right? Does anyone know what that key is called? A master key, exactly. It's a master key. It opens every door on campus in case of an emergency, including all the pod doors, all the front doors, all the office doors. One key for every single door. That's kind of like, yes. How does it work? I have no idea, honestly. I wish I knew how keys worked. I've seen like videos of like cross sections of like what happens when you put a key in the door. I can't understand it still, but we could research that later if we have time. Yeah.
So does that go to someone else's?
Nope. This key only opens my door.
How does it there open the
Like I said, I don't know how the technicalities of keys and locks work. If anyone's parents work as a locksmith, you could probably ask them. They would know more than me. I'm just as simple-minded as all of you. So I don't know how keys work, but for some reason mine only opens my door, and Mr. Amy's opens every single door on campus. So my key has one solution, right? It only opens one door. Mr. Amy's key has many solutions. It can open many doors. In fact, all the doors, like I said. Good morning. You got my type thing? So it was like, it wasn't working, and then like right before class started, it decided it wanted to start working again. But like what I would like hold off, and it would flash and then come back on frozen, but not like freeze frozen, like actually like stuck frozen. Is that like a common, have you seen that happen?
Probably rarely. But you know, it's actually it happens again, so that little bucket that I plug in is your kid after 5 minutes.
Oh, the one at the very top?
Yeah.
Oh, okay.
Plug it back in and then it's like do like the little flashing and all that.
Yeah,
stuff.
yeah, yeah.
So once that's done, yeah, go ahead and turn it back on and that should fix it.
Okay, cool. Because I think now if I try and freeze it, it'll do it. Yeah. Of course, once I submit something.
No,
Sorry for making you come on about. But that's good to know. I'll unplug that if it's acting up again.
yeah, it happened again though. Just let me know if it
Okay.
doesn't fix it.
Perfect. I appreciate it, Tom. Thank you. My bad. So, what was I saying? Oh yeah, I don't know how keys work, but many solutions is something like 2 equals 2, and we've seen this before, right?
Yeah.
0 equals 0. 3x equals 3x. And when we get something like this, we'll see an example of how we can come to this solution. But when we see the same thing on the left side of my equal sign that we see on the right side of my equal sign, we know that we have infinitely many solutions. Just like how Mr. Amy's key opens all the doors on campus, an equation that has many solutions, you could plug any number in, 2, 0, 1/2, and get a true statement. This is what we're used to seeing, right? 2 equals 2. Is 2 equal to 2? Yes, that's true. Boom, we check it off, right? Same kind of idea. So for many solutions, we know that we have many solutions if we have number equals itself. Also known as a true statement, which is what we're used to seeing, like with our unit on functions. This is my house key. Okay? This house key, if I wanted to use it on campus, has no solution. It doesn't open any of the doors on campus, obviously, because it opens the key to my house, right? So we know that an equation has no solution if we see something like 2 equals 3, 1 equals 0, -5 equals 5, or any type of, as we know it before, false statement. So we know that we have no solution if we have a number, that's a D, I meant a B, number equals a different number. Like I said, also known as a false statement. So today we're going to go through some equations and figure out whether they have one solution. If they do have one solution, we're going to just stick to business as usual and find that one solution. But if we find that we have many solutions, we're going to note that we have many solutions. And if we have no solutions, we're going to note that as well. 3 different options, 3 different outcomes, 3 different types of keys. That's the one way that we can think about it, right? Key is a solution to a door. My classroom key has one solution. It opens one door. Mr. Amy's master key has many solutions. It opens all the doors. And my house key has no solution here because it doesn't open any. Just one little kind of way we can connect this to the real world, if that makes sense to you. Hopefully it does. Let's take a look at our first equation. We're going to skip over one solution because, like I said, we spent 3 weeks finding one solution. We should be good on that. Let's find one of the other options. For example, let's say we've got, thank God we're not dealing with fractions today, 2x plus 2 equals 2 times x plus 1. Two x plus 2 equals 2 times x plus 1. There's no fraction busting to do, so I'm going to draw my line. Right, that's our real, well, not real, but that's our typical beginning first step, right, is drawing that line. What number am I going to distribute here? The 2. Again, remember the distributive property. I'm going to distribute this 2 to the x and to the 1. So my left side stays the same, 2x plus 2 equals, now I've got 2 times x plus 2 times 1. What we ended last week with, if you remember, our distributive property on Wednesday and Thursday. Wait, just Thursday. What is 2 times x? 2x. What is 2 times 1? 2. So what we have now is 2x plus 2 equals 2x plus 2. Interesting. Anyone remember what my next step here would be? Perfect, absolutely. We're going to subtract my variable term over to the left, minus 2x minus 2x, and we're going to see something interesting here. What happens with 2x minus 2x? It's 0. We can cancel it out. But over here, we also have 2x minus 2x. So what can we do with those? Cross them out as well. Good morning. So we're left with a 2 on the left equals a 2 on the right, and no variable terms left. So the question is, does 2 equal 2? Yes, it does. So how many solutions do we have? One, many, or none? Many solutions. Remember, an equation is like a machine. You put something into it, you get something out. This specific equation, in this example, we could put anything in for x, and we will get a true statement as our answer. If we plugged in 5, we'd get 2 times 5, which is 10, plus 2 is 12. Plug in a 5 over here. 5 plus 1 is 6, times 2, which is 12. 12 equals 12. True statement. I know it might be a little bit confusing at first, kind of trying to understand the conceptual aspect of this, but really what it comes down to is solving it like normal and looking out for things like this. 2 equals 2. That's good. That means that we have many solutions. That's our answer. Box that up. Many solutions. And there we go. There's our answer. Questions I could answer about that? Do we see how we got 2 equals 2? Yeah. Okay, good. Now let's take a look, obviously, at the flip side of this. You can assume probably what our answer is going to be. Let's say I have 1x plus 2 equals hold on. One x plus 2 equals whatever. We'll just do it. 1/2 times 2x plus 6. I know we've got a fraction here, but it's not bad. Don't worry. We don't have to fraction bust. Here, what number am I going to distribute? 1/2. I'm going to do 1/2 times 2x and 1/2 times 6. I've got 1x plus 2 equals, again, 1/2 of 2x plus 1/2 of 6. I'm going to zoom in. What is half of 2x? 1x. Perfect. What is 1/2 of 6? 3. So now we've got 1x plus 2 equals 1x plus 3. What am I going to do next again? I'm going to move my variable term to the left by subtracting 1x from both sides. And look at that. We've got another one of those double cancellations here. 1x minus 1x is 0. And 1x minus 1x is also 0. So what we're left with is 2 equals what? 3. Is 2 equal to 3? No. What's my answer going to be? No solution. So this is an equation that is like a broken machine. There's no number we can plug in for x that's going to give us a true statement at the end of it. If we plug in the number 1 for x, we get 2 is equal to 3. If we plug in 2, we get 4 is equal to 5. If we plug in 3, we get, 5 is equal to 6, and so on. We're never, ever, ever going to get a true statement. There's a false statement there. So that's what we're looking for. We're looking for true statements. We're looking for false statements. And if we don't have either of those, it's just one solution, which again is what we're used to doing. That's why we're not talking about it right now, because that's what we've been talking about with all these lessons so far, is finding one solution. Questions I can answer about that? Okay. I'm going to get worksheet 42 passed out real quick. We're going to do one of them together. Yes, you asked to go to the bathroom. Okay, go quick, and then Nelly's going to go and go after. I know. Yes. Okay, I'll come help you in 1 sec. I want to go through one question here together, and then we can talk about that. Okay. What number do I want to do? I don't even know.
For the first question, we have to write it
You can just, you can skip that stuff. I know what you're talking about. Let's do number 2 real quick. I want to take a look at number 2 real quick. So number 2. I'm going to keep this in the note video just in case we need some help. Number 2. What number am I distributing here in number 2? -4. I'm going to distribute it to 5v and to the 3. So this was your question, Hope. We're going to skip that kind of middle step. What's -4 times 5v? -20v. What's -4 times 3? -12. So yeah, if you're comfortable with distributing at this point, which hopefully we all are, but understandable if you're not, you could skip that little step where we write each term in the parentheses, okay? All right, I've got a variable and a constant and a variable. I want to bring what over to the left? What am I going to bring to the left? I'm going to take my 5v and bring it over here. What's the opposite of -5v? Plus 5v. Plus 5v. I'm left with -15v minus 12 equals -27. What do I want to move now? The 12. What's the opposite of negative 12? Plus 12. Plus 12. I'm left with negative 15v equals negative 15. Now you may get to this point and go, oh, many solutions. Negative 15 equals negative 15. But not quite, because there's a v in here. What's my last step here going to be? Divide by negative 15. Negative 15. What is negative 15 divided by negative 15? Positive 1. Yeah, 15 over 15 is 1. Negative over negative is a positive for dividing them. And I get v is equal to 1. Does that look like one solution, many solutions, or no solutions? One solution. So there's the example that we didn't have in the notes. Because again, we've been doing this. This is just like lesson 7.3, the distributive property, that we took notes on January 4th. 7.3. All right? There's a pretty healthy mix of one, many, and no solutions on here. So go ahead and get started. We got about 20 minutes left.